that are designed to answer questions like these, but they require a lot of knowledge of math and possibly even programming to understand. And what I want to see is, well, can you just reach in and grab this stuff and twist it around with your hands? So what I'm going to do is I'm going to turn off these axes, and I'm going to move this stuff around, and we feel these objects, moving around as the system is responding to our motions. And I'm going to attach another data point here. Let's see. Okay. So now we got 3 points that are attached. Now I've got 2 of them attached to the red dots, and I've got 1 of them attached to the gray dots. And I can twist these guys around. And whenever I put the system into a state that's mathematically inconsistent, the computer will push back. And so if I just release my hand, you can see it kind of pushing back against me. And if you push the system in a direction where it has to change a lot of parameters in the underlying mapping of these objects to this space, then you'll see, you'll feel it pushing back in that case as well. So I'm just going to twist these guys around and see if I can try to cluster the red dots in one particular area of the graph without blocking the camera. So now we've got a layout where the red dots, let's see. Okay, so now we've got a pretty good cluster, and so we can see that, so we don't have all the red dots. You can see that there's a good cluster here, and we can look over here and see that there's certain different parameters that are driving things in that direction. So LDL cholesterol and FOXP1, which is a gene that's related to a certain heart defect. So the idea here is we can reach in, we can look at the data through these traditional kind of 2D mapping, or we can turn that off and we can grab the data by itself and by actual physical points and twist the data around and try to twist it into a perspective that makes sense for the question that we're trying to answer. Okay, so let's go back to the slides. Okay. So, we're working on making these robots even smaller and cheaper and more responsive. And in the future, we envision them, being attached to everyday physical objects. So I'd like to leave you with the idea that maybe this is the computer of the future. It's just an ordinary coffee table. And, there's nothing special about it at all in terms of technology. But when you have a complex problem to solve, you can, tag the objects on the table, tag any sort of everyday object, and turn that surface into an interactive space where the objects become alive to help you solve a complex problem. Thank you very much.